let's start. We have a lot of things to cover today. As usual, let's start from introductions and what we're going to do today. So my name is Oleg Ishchuk. I'm in charge of operations at SDC Verifier. And as some of you may know, also, I would like to make sure that you can clearly and loudly hear me. Petro?
Yeah, I can hear you.
Okay, all good.
Well,
Thanks. So yeah, I'm joined here by Petro Nek, who is in charge of our marketing, and Bogdan Melnik is going to help us with all the complex technical stuff, as usual. So coming back to the purpose of this webinars, or series of webinars to be correct, some of you may know that we have launched a new product 2 weeks ago, SDC Verifier, that works independently without the need to connect to an FEA software. And with this series of webinars, we are going to cover the workflow with this new product. So we will speak about, today we are going to speak about modeling within new SDC Verifier. Next Thursday, we will continue with the same model and do the finite element analysis, applying the loads, boundary conditions, and analyzing the model itself. Then we are going to speak about checks and the ways to present the results. So let's jump directly into the action. I'm going to remove this start screen. And then, yeah, let's start completely from scratch. I have SDC Verifier installed on my computer. As you can see, SDC programs for FEMAP and System Center had this green logos, new purple logo of SDC Verifier independent software. And this is how it looks. I'm going to maximize the window. So in this version, we are having, or in this software, we are having our own graphical interface, our own functionality for modeling, our own functionality for meshing, building the models, importing. What is very important is the fact that we are able to import the geometry, the finite element models from other softwares, and some output files. So, but today we're going to focus on modeling from scratch. Nevertheless, the important thing to explain and to mention is that this new product, which we are calling SDC Verifier now, is added to the line of products of our company, and we are not anyhow stopping or suspending the support of existing products. So SDC for ANSYS, SDC for FEMAP, SDC for SimCenter 3D are continuing being developed in the same pace, at the same with the same attention to details as usual, and all the functionality that is available or is going to be available will be included in all the products in our product line. If you are using ANSYS FEMAP or SimCenter with SDC Verifier, then basically the idea is that you only build the model in other softwares or already have the model that is prepared by someone else. So once again, today we are focusing on modeling, and what I'm going to do is to start a new project. So to start from, excuse me, just a second. Please mute yourself if you're not, if you're joining the meeting, so not disturbing and distracting anybody else. Okay, so we're starting from creating new project. So to do this, I go to File tab and I click on New. And the window is pretty much standard, as you are already used to. You can define some number for the project, and then you have a name window where you can fill in something. Let's say today we start with webinar or SDCV series of webinars, because we're going to work with the same project for a long time. And here you can fill in the customer and engineer details. As usual, if you have done it once, you have a library where you can fill in and store all the information. So I'm just going to load the engineer and customer details. You have to do it once for your company and your clients, and then you can load this stuff. And when I press OK, the new project has been created, and we can start either from importing the design. So basically by just drag and drop, you can import different CAD files, you can import different geometry types as well as models. But this is some of the features maybe I will highlight separately in the next videos. Today we are going to speak about building models from scratch. So to do this, we have a couple of extra tabs in SDC Verifier window, and we are going to start from geometry. This tab allows us to create points, lines, surfaces, solids, adjust them, copy, modify, and remove, of course. So we will start, simple way to do things is to create a point. So if you click on this point button, you have a menu that allows you to create a point by coordinates. There are multiple methods for creating basically anything. Within this graphical interface, you can click on methods and select, do you want to locate this point by coordinate or clicking in work plane. You can select if you would have other geometry, you could do that on a specific geometry, but we would basically just create a point in the coordinate of 0, 0, 0. And if I press OK and then close this window, you see that where we had the center, the yellow point button has been created. What you can do, what we can do else is create another point. Let's say with a coordinate 0, 0, and 3 meters. Well, this system is unitless, so it doesn't matter what value you type in here. I decide to model with meters, so I'm going to type 3 as 3 meters, and then it's done. And if I take a look on this model now, I have created a point with 3 meters in Z direction. So I would assume that Z is going to be my vertical axis, right? What we can do next is creating a line. If I'm clicking on this item over here, we have line here and different functionalities and different options to create line. I like to create lines by coordinates. So I click on coordinates. And again, here I can either type in this value or just click on these buttons. If in the method, I select locate. And if I click with right mouse button on the graphical interface, I could select what to snap to, how to locate. So I'm selecting snap to point. And when I'm snapping to point, I am able to locate these points, as you can see now. So I'm selecting one of those points, pressing OK, then selecting the other one, pressing OK again, and I have a line created. What I can do now is to create another line just by coordinates. So I'm clicking line, I'm clicking coordinates, and let's say we will make a new one 3 meters away from this in X direction. So I would type 3, 0, 0 for a first coordinate of line. And then secondly, I would do 3, 0, 3 to create a second point. And the line, another line has been created. What we can do next, I would say some part of work has been already done, so it's smart to save the job that was done. If I go back to File tab, I click on Save, and I can run and I can create this project file, SDC Verifier project. So we could call it webinar demo and save. Okay, I recommend saving often. That's always good for any type of projects, documents, or software you're working with. Going back to geometry tab, we are continuing building our model. So now we have these two lines, and I would like to copy those lines. So if I go to copy section on the geometry tab, here I can select the entity that I would like to copy. Let's say I'm going to copy serves. So I select these two serves, press OK. You can select them by just clicking on the graphical interface. You can select them by ID. You can also define a method on how would you want to select the curves. I'm selecting this too, and how would I like to copy it? I would like to move along the vector, do only one repetition. That's basically all the parameters I need for now. And now I have to specify this vector. So how I want to copy this is from base point of 0, 0, 0, let's say 3 meters to the side in y direction. So I change this one to 3 meters here. You can also specify the vector by clicking on the points, but now I like to work with coordinates. Yet still you have different methods to locate and to define. So we are going to copy these lines 3 meters to the side. I'm pressing OK, and now I have these lines copied. Now let's make some sort of a tower. So I will again create lines by coordinates. Let's say 1, 2. So just to show you how quick and easy it is to create this, just by defining the lines. I closed this, and maybe let's make 1 or 2 more repetitions. So what we will do, we will go to copy, entity, serves. With a box select, you can pick all of these lines, click OK. I want to do 2 or even let's say 3 repetitions. Maybe it is, maybe I want to add some diagonals, but we'll see. I would do 3 repetitions, and I want to copy them up. So from here up till here, 3 repetitions, press OK, and we have kind of a tower already, geometry. Okay, for an extra stiffness, well, for an extra stiffness, we would need some braces and diagonals and so on. So what I want to do in this case, let's say I want to do a couple of diagonal members. Let's create them again by coordinates. And I would do from this corner to this corner, and from this one to this one. The same I will repeat on the other side. But it is important to understand that if I'm selecting this line now, so for example, here, you can see that this is a continuous line and we want the mesh to be split there. So we want to break those lines to make a node in the middle, a split in the middle. So we would do to modifying, serve, and break at location. So I want to break these 2 serves and these 2 serves in a certain location, which would be in the middle, but I cannot select this middle here. So I go to methods and select intersect serves. So I would break on the intersections of these 2 serves. I select serve ID 1 and 2, press OK, and now you can see that it's modified and we have them split. In the same way, we can split these lines maybe halfway or so. What I would do is probably I would copy for some consistency in this design. I would do, let's say, copy the serves again. I'm just creating this geometry out of my mind with no specific idea in mind, but let's make 1 repetition and copy these lines from here to here, press OK. So we have something here. Maybe let's do some diagonal members on other side. So again, continue with creating lines, and let's do by coordinates. Method is now being remembered. So we see that the method is intersection of serves. So we switch on methods and go to locate. And we just have to locate the coordinates, and we'll do 1, 2 here, then do the other way, the other way. We're going to make checks on this model later on. So I think making it quite stiff is not a bad idea, but we'll see. And let's do something in the opposite direction on the other side. So by coordinates, again, I would do from here till here. This one, once again, the first location, second location. I would say it's already quite a lot of members. So maybe we don't need that much. Let's delete something. Delete is easy. In this geometry tab, we have delete section, and I can select what I want to delete. Let's say I want to delete serves. So I remove this two, and maybe this two, not to make it look too messy. Press OK, delete it. Now these members are deleted. So on some sections, we have this crossing. On the other sections, we have just 2 diagonal members on the sides. I think that's going to be enough. Now we want to create some sort of a surface, let's say, on top, right? Some sort of deck on top of our tower. What I would like to do, I would just copy these lines. Let's say copy entity serve this two with 1 repetition just from here till here. Done. The same. If I do a right click on this graphical interface menu, I will receive a possibility to pick previous command. So it's nice to repeat. I select previous command, select this two, 1 repetition, now from here till here. Let's do the same in other direction. These 2 lines, copy from here till here. And again, previous command, these 2 lines, copy 1 repetition from here till here. We are creating some sort of heli deck on top or so. So let's now close these lines. Again, line coordinates, selecting 1, 2. So I'm just closing this loop by defining the coordinates. And this two, done. And now let's make some surface on there. So to do this, we go to surface section and select, let's do this by edge surface. When I'm selecting edge surface, I can create a surface by defining the edge surface either 3-sided or 4-sided. So if I want to close this gap here, I select 3-sided and I click on 3 surfaces. 1, 2, 3. Done. Then I have 4-sided by default. So I select this one, closed. So I'm selecting each and every of them separately. We could do the other way around. We could do a surface and imprint the lines on that surface. But I'm trying to show here the most basic way of creating geometries. So in a simple and very intuitive way, we are defining this surfaces here. Let's do 3-sided. Okay. And the last, this is wrong. And the last one, once again, 3-sided. Okay. Okay, we have some sort of a surface on top, maybe for the future recognition of welds and stuff. What we can do we can maybe do a bit of extra layer. So let's say we will, let's continue in the same way. We will copy these lines of the edge. So I go to, let's maybe go back to File tab and save our project. Okay, backups are also saved often and frequently. I think in preferences, you can define the, yes, backups are saved every 15 minutes. So here you can see that, but never too bad idea to save it model again. Let's go back to geometry, copy, and we will copy surface, and we will copy this edge surface, all of them. Was one repetition, let's say 1 meter up. So 0 here and 1 meter in that direction. Press OK. Okay, I also have some points imprinted here. What we are going to do, I think 1 meter is too much. Let's do previous command and let's do a bit smaller gap over there. So let's do 1 repetition, but with, let's say, 30 centimeters, so 0.3 meter. Okay. And now I want to create the surfaces, these vertical surfaces here. If we want to keep the same logic, we can create them either by defining the corners. So I click on corners and I say 1, 2, 3, 4, and I'm creating this kind of surface, right? So this is a bit routine, but a quick way to create the surface. And then the last one. Okay, I think this is enough for demonstrating the geometry modeling capabilities. I think now you have more understanding on how quick and easy it is to create your own geometry from scratch within the graphical interface of SDC Verifier. And what we have to do now is to create mesh, right? So we switch to the mesh tab, and we're going to prepare the settings for the mesh. But first, I would say, let's go with materials. So if I go to model section in the tree, I have materials here. So what I can do is execute a right click on materials and add a material. So let's say what we want to create is regular steel. So it's going to be steel. And we can immediately define here some parameters for the material. So it's going to be the Young's modulus, which is 210 E9, Poisson ratio, so 0.33, the density of 7850 for steel, and yield and tensile, let's say it's going to be steel S355 for which, or S240. S240 with yield stress of 240 megapascals and tensile strength of 355 megapascals. Clicking OK, and material has been created. From here, we want to create some properties. Let's do them one by one. So let's start with these columns or the legs that we have created. Let's go to properties, right click, add. And here we can able to define the property. First of all, we have to pick the material. So create the steel, select the steel we created or create a new one. Here we have new one with more parameters defining here, but we already have created this steel. And now we are going to create a property type, but you can see it's plate element type. So we want to switch to beams, and it can be done here, where you select element/property type, and instead of plate, you can see plenty of different finite element types, but we are going to focus on beams and plates today. So we are going to create regular beam property. Okay, to define this beam property, you can either enter all of these parameters, which is quite a lot of work, I would say, or click on the shape button and create some sort of property. Let's say these legs are going to be rectangular bars, rectangular tubes. And for this rectangular tubes, we are going to have, let's say 0.2 by 0.2 meter, and with a thickness of 10 millimeters. If I click anywhere here, I would see all the parameters of this. So maybe 25. Immediately I see the cross section. Pressing OK, the moments of inertia and stuff are calculated, and the only thing I have to do is to give it a name. If I just press OK, it will give it some sort of standard name like beam property or beam1 or so, but I encourage you to use good names for all the variables you're creating in your project. So let's say it's going to be box shape of 250 by 10, if I am not wrong. Let's click on shape again. 250 by 10, right. Box 250 by 10, press OK, and the property has been created. I can close it now. Our property is here, and let's mesh something first, then we create more. So to define the mesh, first I would prefer to define the amount of elements per length. So I can go to mesh control and say size along surf, and I would select, basically I would select all surfs, click OK, and I would say that on all of the surfs I want to define the element size, which would be, let's say we have 3 meters here, 0.3 meters, so we will have 10 elements per length of the beam, and here we will have, maybe on plates we will adjust later, but for beams I think 0.3 is fine. We will have 10 elements per length, which does seem okay for me. Press OK, and the mesh size is displayed. Now I want to mesh these lines that I have created. So I go to Mesh, Geometry, and select what part of what type of geometry I would like to mesh. I select the surface, and now I have to define the surface I want to mesh. So I'm selecting the columns I have created, and all of these columns, I'm going to define them. I can highlight them by clicking on this button, so you can see whatever we have selected, and I press OK. And here from the list, I can create a property with which I'm going to mesh my model. I'm pressing OK, and I need to define the y-axis for the beam. Since it's box, which is having same side, doesn't matter much. The X direction is going to be fine for everything. So this vector can either, again, be defined by clicking or by coordinates, pressing OK. And the mesh has been created, but we don't see it yet because in the view options here, we need to define the thickness on. So if I switch the thickness on, here we have the elements that are created. Okay, what do we want to adjust next is to create this kind of floors. Let's do a new property for that floors. We add property. Again, it's going to be a beam property, but let's change the shape. Instead of a box, we're going to use an I-beam. An I-beam needs a bit more options. We had 250, let's say 200 of height. Width is going to be, let's make it the same, 200. And then thickness on top is going to be 10, thickness on bottom again 10, and thickness of the web is going to be 8 millimeters. This is the way we create our I-beam. Press OK. Let's call it I-beam. I-beam, what was the height? 200. I-beam 200, and we click on OK. I can continue creating properties from here. So let's do the one for diagonals immediately. I click on shape, and let's do a circular tube with a radius of 10 or maybe even 150 diameter, so 75 of radius, and 6 millimeter thickness of this tube. Press OK and call it tube 156. Press OK, close it. Properties has been created, and let's mesh the lines we have now. So we go to this floors, we go again, geometry, surf. I'm selecting this, all of the stages that we have done here. Let's leave this for now. I'm pressing OK, and I'm selecting the property I-beam 200, defined, OK, and vector. This is something that I would have to adjust because they are perpendicular to each other. So I need to define Y for some and X for the others. So I'll do that once again. Previous command. First, I select this one, which are aligned along the X, I-beam 200, okay, and vector for them will be Y. Why it is? Because we need to make it perpendicular in Y direction. So pressing OK, I-beams have been created. The next one, previous command, we select this lines here. And for those lines, keeping the same property, but the vector is going to be in X direction. Pressing OK, I-beams have been created. And the last but not least is to define diagonals. We go again, geometry, surf, and we select all of the all of these smaller items. Of course, yeah, you can create much more, and in your real project it will be a bit more complicated design probably, but I think this is enough to indicate the capabilities. We created this lines here. We selected these lines, pressing OK and selecting the cube that I have created. Pressing OK. Vector should be fine in X direction. Let's see. Yes. Okay. What we can do also for nice representation of this, we can color the elements with property colors. All the properties are the same. So what we can do is to edit the colors for the property. Maybe this, sorry, I copied, remove that one. So if I click on edit, this one can be kept green, and edit this one, we will do some sort of dark red. Okay, so for a bit better visual representation on your model. In this view, you can also select different options. So do you want to see the fillet edges? Yes or no? Do you want to see some sort of transparency? So to look through the model on these connections, how is that created? So on. So all the view options are here. I'll switch off the transparency. And in this panel above, you can select what would you like to see in terms of points, lines, surfaces, text, coordinate systems, nodes, elements, constraints, and loads, and so on, which we don't have yet. So if I only want to see elements, I select these elements, and these are the elements that I have created. But let's keep everything for now because we need to continue with our model. Quick save, and we go to mesh tab, and we are going to mesh let's mesh the surfaces first. So we do mesh control was defined on the surface. I think that is enough. Now we need a plate property, right? So we go to properties. Well, we can also do this the other way around. We go to meshing the geometry, select surface. If I select all of these surfaces, the bottom ones first, I switch the view to pick normal. This is picked, but we need to remove this one. I think I clicked something wrong. Okay, if I highlight, yes, we selected this full deck. Okay, and now I need to define the property, but it hasn't been created yet, right? So I click on this button to create a new one. And I need to create a plate property. The only parameter that has to be defined for the plate property is thickness. So let's say 10 millimeter plate. So 10 millimeters of the same material, pressing OK. How do we want to mesh it? As much as possible with quad elements, with no mid-side nodes. I'm clicking OK, and the mesh has been created. There is a meshing toolbox that helps you to increase the decrease the amount of elements over the line. I won't be playing with that now, but what we also can do, and I think a big addition to SDC Verifier, you can undo with Ctrl Z. So it's always possible to undo stuff in a certain way, but for the moment, I think we will keep this as it is. And we are going to mesh this this sides with a smaller property. You also see that this property haven't appeared here. We have the update model here with continuing with the existing results, pressing on OK. Model properties. Here is our plate property. We want to add another plate property. Let's do this in a classic way, or the way I showed you before. We go to properties, add, and from the same steel, I want to do 8 millimeter or even 6 millimeter plate. For this, I go to thickness 006. OK. And what I would do now, I'm going to mesh this with this plate. So I go to mesh, geometry, surface, selecting this side surfaces. Yes, all of them. Mesh size was defined already with the property of 6 millimeters maximum quads without mid-side nodes, pressing OK, and the side wall has been created. So I think now it is a bit too much. Let's switch the fillet edges off or the nodes off. I think we can also get rid of the geometry at the moment. So this is the tower that we have created. But if I switch the lines back, you would probably remember, yeah, it doesn't look like a decent design with having this 4 pillars coming into a plated surface. It will rarely pass any plate buckling check. So what we want to do is to add some stiffeners on these lines that we have here. I'll switch on the lines so we can get rid of elements for the moment. So on these lines, I want to create some sort of stiffening elements. Let's create one more property. We'll call it, how are we going to call it? We are going to, add. We are going to create another element type, beam. Okay, and let's do some sort of T-shape or angle section. Let's do, or maybe just a rectangular bar. Let's do a rectangular bar, but with the height of, let's say 10, and with width of 10 millimeters. So this, maybe let's do 12 and 8, something like a stiffener here. Pressing OK. 12 millimeters, and I will call it bar 12 by 8, 120, sorry, by 8. Change the color of it to yellow, and I will press OK. The property has been created, and now let's mesh this final line. So geometry serve, we select all, we also would need to define the direction. So first we mesh this ones. So I mesh 1, 2, 3, 4, 5, 6 lines, highlighting those lines for you now. So, and the the y direction for them will be global y. I'm defining this property of bar 120x8, and the y direction is going to be global y. Pressing OK. Switch the elements on. Yes, I'll show you another thing was offset for these elements in a second, but let's add the previous command and let's add a bit more of this. Okay, and defining them with the same property, but global x is going to be the direction of them. Okay, now we see that we kind of have this stiffener crossing the surface that has been created, and we would like to add some offset. What I would like to do, I would probably go to this property, select edit, and here I can define the offsets. So we want to adjust them vertically, and we want, since it's 120, so it's 0.6. Just a second. Okay. So I have defined 0.06, and I'm clicking on OK. It's just the orientation of some of them has been adjusted, right? So I need to make sure that my y-axis for all of those properties is defined correctly, but we don't have much time in this webinar left. So what I'm going to do, I'm going to show that slightly later. For the moment, we will switch this offsets. This is for this now we have them. Sorry, I did an undo, and if I will undo again, do I have that meshed? No, I removed the mesh of it. So I'll go back to edit. What I did an undo for this. Let's recreate that very quickly once again. So I go to serves. Don't show this element. Just a second. So don't show the elements in the nodes. I want to mesh geometry serves. The orientation of y-axis is important for offsets. I'm going to explain that slightly later, but let's select this bar and with y-axis here. Okay. And maybe turn on the mesh so we can see it. And then previous command, let's do the same. Okay. And the same bar with the orientation in global y. Okay. I think I did wrong orientation. So this lines Yes. And we do the same bar, pressing OK, but orientation should be global X, right? Pressing OK. Okay. Good. So we have created the stiffener. I'm going to go back to File tab, save the model, once again show you, I'll remove the nodes and lines and points, and I will show you the fillet edges of the elements. So we have meshed our model. 45 minutes, just as I planned to fit in this session today. So quick sum up. We have had the first demonstration of SDC Verifier standalone interface, which works independently from other FEA tools and allows you to create the model, apply the loads, analyze it with the solver, which we're going to do in our next session next week, and then do checks according to rules and regulations, documentation, and all the functionality of existing SDC Verifier feature. So in less than an hour, we build a simple model of tower. I think it is possible to do it in 15 minutes, but I spent some extra time on explaining the details and buttons and stuff. The functionality of this geometry and mesh tabs are much more extensive. You can create much more complex geometry. You can modify by copying, rotating, reflecting, doing all kinds of modifications with geometry. Mesh is enhanced with meshing toolboxes. It is possible to adjust the mesh, revolve, extrude, remesh the surfaces or solids or surfs. So all the functionality of building the finite element model is here. We just seen some very primitive way to build simple models, but we are going to build a nice use case by in 4 sessions. We are going to go the complete through the complete project.